Machine learning is a subfield of artificial intelligence, AI, that involves the development of algorithms and statistical models that enable computer systems to automatically learn and improve from experience without being explicitly programmed. In other words, machine learning allows computers to learn from data and make predictions or decisions based on that data. The basic idea behind machine learning is to enable computers to automatically learn patterns and relationships in data, and to use that knowledge to make predictions or decisions about new data. This is done by training a machine learning model on a dataset, which consists of input data, also known as features, and corresponding output data, also known as labels. The model uses the input data to make predictions or decisions about the output data, and then adjusts its parameters based on the error between its predictions and the true output data. There are different types of machine learning, including 1. Supervised learning. In supervised learning, the dataset consists of input data and corresponding output data, and the goal is to learn a function that maps the input data to the output data. Examples of supervised learning include classification, where the output data is a categorical variable, and regression, where the output data is a continuous variable. 2. Unsupervised learning. In unsupervised learning, the dataset consists of input data only, and the goal is to learn patterns or relationships in the data without any labeled output data. Examples of unsupervised learning include clustering, where the goal is to group similar data points together, and dimensionality reduction, where the goal is to reduce the number of input features. 3. Reinforcement learning. In reinforcement learning, the goal is to learn a policy that maps states to actions in an environment, such that the cumulative reward over time is maximized. Reinforcement learning is often used in robotics, gaming, and other applications where an agent interacts with an environment. Machine learning has many practical applications, such as image and speech recognition, natural language processing, recommendation systems, and predictive analytics, to name just a few. As the amount of data continues to grow and computing power becomes more powerful, machine learning is becoming an increasingly important tool for solving complex real-world problems. Sure, here are some additional details about machine learning. 4. Deep learning. Deep learning is a subfield of machine learning that involves the use of neural networks with many layers, hence the term deep. Deep learning has been particularly successful in areas such as computer vision and natural language processing, and has enabled breakthroughs in areas such as image recognition, speech recognition, and language translation. 5. Feature engineering. Feature engineering is the process of selecting and transforming input data in order to improve the performance of a machine learning model. Feature engineering is an important step in the machine learning process, and often involves domain-specific knowledge and expertise. 6. Hyperparameter tuning. Hyperparameter tuning is the process of selecting the best set of hyperparameters, parameters that are not learned by the model, but are set by the user, for a machine learning model. Hyperparameter tuning can have a significant impact on the performance of a model, and is often done using techniques such as grid search or Bayesian optimization. 7. Model evaluation. Model evaluation is the process of assessing the performance of a machine learning model on new data. Model evaluation is an important step in the machine learning process, as it allows data scientists to determine whether their model is generalizing well to new data, or whether it is overfitting to the training data. 8. Transfer learning. Transfer learning is the process of using knowledge gained from one machine learning task to improve the performance of a model on a different task. Transfer learning has been particularly successful in areas such as computer vision, where pre-trained models can be fine-tuned on new datasets with relatively little data. 9. Explainability and interpretability. Explainability and interpretability are increasingly important topics in machine learning, as there is a growing need to understand how machine learning models are making decisions. Explainability and interpretability techniques can help data scientists to understand how their models are working, and can help stakeholders to trust and adopt machine learning solutions. These are just a few more details about machine learning. As you can see, machine learning is a complex and rapidly evolving field, with many different techniques and subfields. However, at its core, machine learning is about enabling computers to learn from data and make predictions or decisions based on that data, and it has many practical applications across many different industries.